Hey everybody, today we're going to talk about similar figures. Now the concept of similar figures is similar to the idea of being congruent. So congruent means that things are exactly the same, right? The idea of similar, on the other hand, is that they're kind of the same. How do you be kind of the same? Well, what if you have the same shape, but a different size, right? Think about Hot Wheels cars, right? Hot Wheels are like miniature versions of cars, right? But generally speaking, the design of the Hot Wheel is the same as the full-size car, right? Obviously, sometimes Hot Wheels are crazy and not based on real cars. But if a Hot Wheels, right, if a little Hot Wheels car is based on a real car, then it's going to have the exact same design, just a smaller version of that, right? That's what we mean by similar figures. So they're the exact same shape, exact same design, but just shrunk down. Now, some properties of similar figures: all the angles are going to be congruent. Just like, again, in congruent figures, the angles are the same. But the side lengths are going to be different. So you get the same angles, but different side lengths. Now, what's special about the side lengths, even though they're not the same, they are proportional. Remember what a proportion is, right? It's when you take one fraction equal to another one. 1/2 equals 1/6. And if you recall, you can use cross multiplication to prove that they are the same, right? 1 times 6 is 6. 2 times 3 is 6. Doesn't that prove to you that those two fractions are the same? 1/2 equals 3/6. So let's just look at some examples of this. So the first thing I have here are two triangles. You might notice one triangle smaller than the other one. So if you look at the side lengths, 2, 4, and 5. Now this triangle is 4, 8, and 10. So think about the numbers 2, 4, and 5 and how they relate to 4, 8, and 10. Isn't 2 times 2, 4, and 4 times 2, 8, and 5 times 2, 10? So this triangle is twice the size of the smaller one. Now, to show that these are similar, right, in order to show that they're similar, I'm going to show you that the side lengths are proportional. Now, there's a couple different ways you could do this, but here's my method. Do you see the smallest side of this triangle? 2, right? 2 is the smallest one. That means this side should match up with the smallest side of the other triangle, right? So the smallest side, 2, matches up with the smallest side, 4. So I'm going to make a fraction 2/4. Then I'm going to take the largest side, 5, and I'm going to match that up with the largest side here, 10. So 5/10, set them equal to each other. So I just set up a proportion, right? Smallest over smallest, largest over largest. Could I have done 4/8 as well? Yes, I could have. I just didn't need 3 fractions. I only need 2 of them, right? So anyway, couldn't I use cross multiplication? to prove to myself that these actually are the same fractions. So 2 times 10 is 20, and 5 times 4 is also 20, right? The cross multiplication gives you 20 equal to 20, which means that these fractions are equal, right? So no, the side lengths are not the same, but when you make fractions out of them, they are the same. That's what's special about similar figures. Down here, I have 2 rectangles. One has 3 by 5, the other one is 6 by 10. Once again, you can notice that this one is basically double the size, right? 3 times 2 is 6, 5 times 2 is 10. Now there's actually a couple different ways you could have set this up. Let me show you the same method I was using up here. Let's take the smallest side, 3, and put it over the smallest side here, 6. So 3 over 6, and then 5 over 10, the largest side over the largest side. So 3 over 6 equals 5 over 10. Let's use cross multiplication to check that. 3 times 10 is 30, and 6 times 5 is 30. So you get 30 equals 30, proving to you that these are similar rectangles. But there is a different way I could have set it up. So instead of taking the smallest and the smallest, and the largest and the largest, I could focus on this triangle here, rectangle, this rectangle here, and I could take the small one and put it over the large one. So 3 over 5. You see that? Small over large. Now in the other rectangle, I will take the small one and put it over the large one. 6 over 10. Cross multiply. 3 times 10 is 30. 6 times 5 is 30. So you have 2 options. Small over small equals big over big, or small over big equals small over big. Let me write that down so you can when you see it, it's a little bit better. Do that in blue. So you got 2 options, right? You have small over small equals large over large. You see that? Or you can do small over large equals small over large. So 2 different options for your proportions. Let's just show that in this example up here. So the smallest, so small over large would be 2 over 5, right? And on this one, small over large would be 4 over 10. Cross multiply. 2 times 10 is 20. and 4 times 5 is 20. You get 20 equals 20. So really you have multiple ways you could correctly set up the proportion, as long as you keep it small over small, large over large, or small over large equals small over large. Now, let me show you the types of problems you're actually going to be doing in this section. So what I've done here is I've given 2 examples, right? I'm telling you the polygons are similar, and your goal is to solve for x. Now, in our examples, the shapes are going to be drawn so that each side matches that same side. What do I mean by that? You see the x? Since that's the bottom of the triangle, it's going to line up with the 8. Since the 15 is on the left side, it's going to match up with the 5 on the left side. So I'm going to have to make proportions. And I have 2 different options. How about I take the 5 over the 8? So let's make a fraction from this triangle, 5 over 8. So that's taking the small one over the large one. So if I do 5 over 8, I would have to do 15 over x. So just look at that and make sure that that actually makes sense, right? 5 over 8, 15 over x. And then you just solve using cross multiplication. Five times x and 18, or 8 times 15. So 5 times x is going to get you 5x, and 8 times 15 is going to give you 120. So I have 120 equals 5x. Divide by 5, and you get 24. So x equals 24. That's it. Again, let me just show you how it would have worked if you set it up the other way. What if instead you wanted to take the matching sides, right? That would be the 5 and the 15, and then the 8 and the x. So what if instead I put 5 over 15 and 8 over x? So you can see the setup is very different, but the result should still be the same. Let's check that. So 5 times x is still going to be 5x, and 8 times 15 is still going to be 120. Do you notice I still get the same equation that I got here? So when I divide by 5, I still get that x equals 24. No matter how you set it up, as long as it's set up the right way, and there's multiple right ways, you'll still get that x equals 24. So 2 different ways of doing the exact same problem. And then the last one I want to go over with these rectangles. So I have x plus 3 and 10, and then I have 3 and 2. You can clearly see that the 10 is the shorter side of this rectangle, and the 2 is the shorter side of this one. So the 10 and the 2 match up, the x plus 3 and the 3 match up. This is the longer side, this is the longer side. So I'm only going to set this one up once. I think what I want to do is I want to take the x plus 3 and the 10. So x plus 3 over 10, right? These two. And then I'll make a fraction out of these two, right? 3 over 2. Set them equal. So if I cross multiply, remember that's going to be 2 times x plus 3, which we'll have to distribute. And then 3 times 10 is 30. So I get 30 equals 2 times x plus 3. Distribute the 2 first, right? Get 2x plus 6 equal to 30. Now it's just a two-step equation. Subtract 6. You'll get 24 equals 2x. Divide by 2. X equals 12. That's it. So really, this whole section, the hardest part is going to be setting up the proportions the right way. It's really not that hard. One side over the other equals one side over the other. That's it. So that ends this lesson. Your number of the day for this lesson is 56, right? 56. Got it? Good. See you.